Founded in March 2018, Turing.com is known for its AI-supported international platform that connects software developers with remote employment. It provides in-depth developer profiles, rigorous vetting processes, fast hiring, and management solutions for modern-day hiring. Now, being the brainchild of ex-Stanford graduates and serial AI entrepreneurs Jonathan Siddharth and Vijay Krishnan are on a mission to unleash the world's untapped human potential by building a diverse community, free and open to all developers worldwide. Over 1 million developers have already signed up with Turing, all set to revolutionize the market. In an exclusive interview with Analytics India magazine, Vijay Krishnan, co-founder and CTO of Turing.com, speaks on how their AI-powered platform enables companies to hire and manage remote developers with the push a button.
I guess, Jonathan and I, again, conceived of Turing and started it long before the pandemic. Obviously, nobody could have anticipated anything like this. But what was very clear to us during the course of running our previous company was two things. One was that the hiring problem was getting harder and harder. At least at that point, we felt it very, very obviously in the context of the Silicon Valley, and it didn't seem like there was going to be any natural solution with this. Like what Mark Andreessen said over 10 years back about software eating the world, it was progressively happening to industry after industry. And while there were a lot of these companies that were attempting to bring AI to the local hiring game, we felt like ultimately the problem space that they had defined for themselves was much too narrow. We didn't feel like the fundamental problem was with matching talent to opportunity within a 20-mile radius of the location where I'm sitting, since we felt more or less the market was saturated, or more or less the market was efficient. But what we realized again in the course of doing our last company was that there were very, very talented engineers in various parts of the world, and it was possible to make a distributed team work well together. So, for example, while we faced this problem firsthand, we were much like many companies, we were faced with the choice of, okay, do you want to lower hiring standards? Do you want to hire at a slower rate than you would have otherwise? Or do you not want to hire at all? Literally, that was the sort of choice a lot of companies were faced with. We took a fourth choice. We were like, you know what, we will maintain the same hiring standards, but we will be open to augmenting our team with strong, talented software developers from anywhere in the world. So we ended up working with engineers from Russia, from a lot of countries in Eastern Europe, India, China, the Middle East, and so on. A lot of countries that I don't think most people would have touched. The fact that we did a lot of this kind of wild experimentation also gave us a lot more exposure into talent pools in various parts of the world, and how one might go around vetting the talent pool and ultimately helping the remote collaboration itself be successful. So, of course, in our last company, all this stuff was done more or less by brute force. We were not really planning to do anything at the size and scale of what we are doing at Turing, but it gave us a lot of insights into what the solution had to look like. So it was very obvious to us that, around the time we were thinking of starting Turing, that the world had to move this way. Most of the world wasn't thinking this way, but market pressures would force the world in this way. I mean, on one hand, if you have this immense talent crunch, on the other hand, you have more and more talented developers coming all over the world. How can these two things, not come together? It had to come together, and we wanted to be part of helping make this happen. As a $300 billion market, some say it's closer to $1 trillion. Everybody agrees the market is growing, and obviously a lot of companies take a very, very different approach toward this. In our case, I think the specifically novel things in what we do are, first of all, the fact that we are our talent comes from all over the world. So like companies that are in the outsourcing space typically end up having a physical office in one city or a handful of cities, something like that. And under these circumstances, it always becomes challenging to scale your talent pool. You're often left with the choice of either scale up in terms of either sort of keep your scale small, or if you wish to scale, the only way for you to scale when you're dealing with a handful of cities is for your business to be largely about some kind of low skill work or semi-skilled work. Like, for example, is it possible to hire maybe 10,000 or more data labelers in one city without much difficulty and train them? Sure. Is it possible to hire 10,000 really high quality software developers that would be Silicon Valley caliber from one city? You may often struggle to engage in something like that, particularly since the city itself is likely to have its own competitive dynamics and everything. So first of all, the fact that our talent comes now from more than 120 countries around the world, more than 10,000 unique cities around the world, is really, really helpful. Because the one thing, we of course did start Turing with a certain amount of domain knowledge, but even after starting Turing, I have been pleasantly surprised by, I guess, almost how unpredictable the world is. There's always some new city, new country, new place where a certain amount of talent springs forth. Like the same forces that secular forces in the last, I would say, 10-15 years toward more and more internet penetration, cheaper and cheaper data plans and things like that, are also resulting in a lot of talented software developers. Like, in a sense, there's a certain percentage of talented people in various population pools. Certain countries just did not have easy access to opportunities, easy access to ways to for them to up level and get trained and things like that. With a lot of this online course materials, lot of ways to collaborate online, various other things. The talented people in various parts of the country, in various parts of the world, are certainly gaining access to more and more opportunities. So essentially, the fact that we are pretty much location agnostic, and we take the position, hey, we will take talented people wherever they come from. This is definitely at one big piece of the puzzle, certainly. And I'm not aware. Like today, we sign up more than. In total, we have over 1.5 million software developers registered on Turing, and we sign up more than 100,000 every month. To the best of my knowledge, ours is probably the largest developer pool in the world. This definitely gives us, I think, a very, very decisive advantage in a number of things. Because when you look at what most of our partner companies in the Silicon Valley and other parts of the US, and to a smaller extent rest of the world want, they routinely want something like speed of hiring, quality of hiring, volume of hiring, and reasonable cost of hiring, all of them to be satisfied at the same time. Now, having access to a really large talent pool at least gives you something to start with, toward satisfying some of these various conditions. Then, of course, this is only part one. Like, I think beyond this, there is a question of now, if you have as large a talent pool as this, and we all accept that things like resumes carry only a limited amount of information, the question becomes, how are you going to vet this talent pool effectively? And for a talent pool of this size, manual vetting will just not work. There is it can become prohibitively expensive. Even doing it at high quality and running such a large operational processes where there is consistently high quality and consistent interviews with one another can be quite a nightmare to administer. So a big chunk will have to be automated. So we have a series of tests at Turing, and these mostly, I would say, test for what a standard Silicon Valley on-site interviews test for. So they test for computer science fundamentals and programming skills. They test for skills in various tech stacks. They also test for a number of things around soft skills, in the sense of how well are you able to function cross-functionally? To what extent are you likely to be able to function in a job where there's a great degree of ambiguity versus another job where maybe things are better defined, and there is a tech lead that is creating tickets for you to work on, for example. So we test for things like this as well. Then the last point is how one engages in a good matching process. Now it turns out matching is a lot. I mean, maybe I can actually get this get to this specific thing in a subsequent answer. But this is the area where we put a lot of different signals to use, and this is where a lot of most of our exciting machine learning methods are used. Even after the match, we try and we have a product that helps make the resultant remote collaboration itself effective. So today we have we have customers who have say 50 or 60 software developers, all of them from different cities in the world, and they who are working with maybe 3 or 4 teams in the company, and they are still working as though they were all in the same room. Now, how do you make sure this sort of thing happens? This too is quite a challenging thing, and this is what we solve for with the last piece. Because even historically, I mean, if one asks the question of why didn't this happen already, why didn't every Silicon Valley company get built like this? People virtually had objections to each and every one of the things I'm talking about right now. That how do you people would say, okay, I have no idea how to even get a good talent pipeline going from all over the world. I have no idea how to screen or vet them. Like locally, I would use various shortcuts like what school or a company a person went to. Then, of course, lastly, people did have objections about the effectiveness of remote collaboration itself, particularly when the person were in a different location around the world. We solve for all of those, and solving for all of those certainly unlocks tremendous value to both customer and developers alike. In a world where one were operating at a smaller scale or with a much smaller developer pool, often the matching process is a lot simpler. I mean, you either have the sort of developer that the customer wants, or you don't. Today, I think often even doing some basic keyword filtering may, if you're a traditional staffing firm, do that, and you also apply whatever location customer constraints the customer has, which in traditional staffing customers would often have. Such a thing may itself result in no more than say 5 or 10 developers, and at that point you might as well leave it to the customer to decide if they want to interview some of them and make a hiring decision. Now, when you relax a zip code constraint, in a certain sense, it creates a tremendous opportunity, of course, in terms of the volume of the talent pool that you can tap. But of course, then it creates some new challenges in terms of picking from the talent pool. Like today, for a typical job at Turing, it's common to see more than 10,000 software developers who on paper might be suitable for the job. Now, this does cause quite a lot of complications in terms of how do you how do you engage in any kind of effective matching and recommendations? So let's say somebody was searching for an iOS developer, and let's say they did not have strong location constraints. Again, they would probably come up with this 10,000 number. If they wanted a full stack engineer with expertise in Node and React, same thing. And this would be true across a whole bunch of stacks. So our machine learning plays an important role when it comes to number one, discerning customer preferences itself as well as possible, since every customer is not the same. Some customers and some companies do value some dynamic programming problems, and those sort of things in their developers. Some other companies do value a lot more the sort of specific tech stack related skills, how well this person can function in a professional environment, or for example, how well they can deal with ambiguity and various other things. Like on JDs are often pretty much like a copy paste of each other, but often there are these real unsaid but very vital things to do with the company itself and the hiring manager and the team and the type of work they are doing. Like there may be 2 JDs which both say React and Node a full stack engineer, but honestly, depending on the company, depending on the team, what they want could look drastically different. So number one, we try and understand what exactly the company is about and how much weightage to give various things. Second, we've given that we have engaged in a lot of these tests of developers, and we have over time collected a lot of different information about them, both from the testing process, also a lot of other data points from our touch points with developers, from our attempts to put developers before customers in the past. Again, we have various we have multiple product surfaces where we recommend developers to customers. Whether or not a person was shown to a customer and the customer requested an interview versus didn't request an interview, that is signal. Whether an interview in the past resulted in an offer, and whether this is a rematch, or whether that interview did not result in an offer, and what reason was given by the customer. All that is like useful information. And our models use these to enrich a developer's profile. Ultimately, because we have a lot of positive and negative examples, training data examples by way of successful recommendations that result in successful hires, where the collaboration has been very successful and has been going on for a long time, versus the instances where that did not happen. We are able to train our ranking function to assign the right kinds of weightages based on the job, based on the customer, and based on the developer. So this is the most obvious thing. But if you now work backward from here, there are a lot of other places where we have processes that involve a mix, an interplay between human operational processes and machine learning. So, for example, there might be certain jobs where a company has a specific geographic constraint and also comes up with a very large bulk hiring demand. Let's say a company comes up with 50 jobs that they would like to have filled immediately. Maybe we are able to pull 20 immediately in terms of the developers that have gone through the entire suite of tests and so on, that we are able to recommend with high confidence. The question then becomes, how are we going to fill the other 20? And now, here again, our machine learning models are able to engage in various in scoring developers that are earlier in the funnel in terms of who is likely to be most promising, who is likely to score well in our tests, and so on. And as a way to help people in our talent operations teams spend more time focusing on the developers that have a higher probability of doing well in our tests, encouraging them to go through our tests and so on. So in a sense, so in a sense, this also helps with certain forms of our operational processes being optimized. Then today, today our developer vetting process is, as I mentioned to you, more or less fully automated, but we are willing to put talent operations effort to use on a limited basis among the developers that are most promising, or on developers with certain skills, where we do find quite a shortage on our platform relative to the customer demand. And we find this for a number of things routinely as the market demands keep shifting. So here too, for example, modeling the probability that a developer will start with a customer and doing that in various places in the funnel and using that as a way to guide our operations processes. These two are things that we have found quite helpful. Lastly, our machine learning processes are also helpful for, I guess, designing, not designing per se, but improving our tests themselves. So today we use various measures of information gain on our tests to figure out how useful are various questions versus being a waste of time. Like ideally, one way we think about a test itself from first principles at Turing is that we have a certain baseline amount of information when a developer signs up at Turing and uploads their resume. And we see the purpose of our test as being as something where we should collect, we should be able to move either upward or downward the probability that a developer will get matched with a customer as rapidly as possible with every minute of testing. So in other words, how can I ask you the most useful questions that give me good predictive power, but do that also in the shortest possible time? Since developers, of course, don't have an infinite amount of time for us to take our tests. So the more predictive signal there exists, the better. So here again, the notion of modeling information gain or modeling expected information gain rather based on what questions a developer has answered well until this point. What are the areas where a model sees the highest uncertainty in, and what are the areas where the model feels confident enough that we are past the point of diminishing returns and there's no point asking more questions. All these sorts of things also help us with the vetting process. But this part of, but in this area, our work is relatively more preliminary compared to work in the matching system. But we expect to make a lot of progress in a number of these areas this year. So number one, I would say some of the newer stacks or newer technologies that have got enough traction in the market are often are often attractive skills to acquire, since routinely the market has much more demand for those compared to the supply in the market. Like for example, we often find that we are a little bit more supplied with Java developers compared to the market demand, at least among the new emerging tech companies. Though our some of the larger legacy tech companies that work with us, they do hire developers with these skills in somewhat older technologies as well. The React and Node stack is very popular, is by far the most popular one at Turing this is definitely an area that's that I think has served developers well. Rails, for some reason, we have seen a more or less chronic demand supply mismatch for at least the last 2 or 3 years, and I don't know why, but I think it's not like its demand really compares to this React and Node full stack set, but it is still quite high, and the supply is for some reason perpetually so low that generally developers that are even reasonably good in these areas have a much higher probability of getting hired. In addition to this, all the other usual things, skills with iOS development, Android development, all these things are helpful. Some of the other front-end frameworks we have not seen as much demand for, like Vue and Angular. We see relatively less demand for. We see relatively less demand for PHP these days compared to what used to be the case maybe 5 years back, etc. And when it comes to data science and machine learning itself, I think by far, I think one, I would say we find two categories of skills relatively more, relatively less present than they should be, and because I probably suspect that a lot of training programs and other things maybe do not emphasize these as much. So first one is that when it comes to machine learning, there are a lot of people that have thrown various models at various things, but do not understand the fundamentals well. And often in our experience, I find, it's not just bias creation and such things which is a problem, but even actually producing really effective results when you're trying to go to a fairly when you're handling a somewhat novel problem in the industry, it is difficult to do that without understanding the fundamentals well, because the space of modeling options in the machine learning world is very high. Like let's say you have 10 different parameters, each one of those 10 parameters or modeling options, and there are 10 ways to model each one of those. 10 per 10, it's already crazy high. You better have some framework which tells you, okay, all these paths are a no-go, all these paths are a no-go. I will first explore this, and so on. And often fundamentals can be a very good way to deal with the mathematical underpinnings and all that stuff. Now, some university programs definitely do a fairly good job at this one, at teaching these. But I think a couple of the things that university programs don't do a good job of, and I would encourage more of them to do it, is a lot of things around how to even do good quality data analysis and good insights. Often people think, okay, the way you train a person to be a good data analyst is teach the person Python, teach the person SQL, and you're more or less done. No, the reality is there is an added angle here. Like if you look at, for example, the sorts of things that people who go into consulting get fairly good at, they get good at a lot of things around the around business aspects, where the big opportunities are, how to deal with sort of ambiguity in a problem and get it down to a somewhat structured form where you can solve something. How to even do effective data exploration, how to even do a good presentation which conveys what you want to convey. Today I think there's a tremendous sort of gap in this specific area, and this is often step one to even being able to do any good data science or machine learning effort. And unfortunately, I feel like almost no program seems to teach this. Some companies that have a good data science culture, I think people after working there for some period of time manage to pick up this. A lot of companies don't have this either, because I don't think anyone up to leadership knows how to do analysis well in many of these companies. Yeah, I do think going forward, people that are very strong with ML fundamentals, very strong with doing good analysis, have business sense, and understand the latest in the tools and technologies will be very, very valuable across a whole range of problems. Today, it is not. Today, it's not like various industries don't want to use machine learning and DS methods to ultimately create a lot more business value. It is just that they have often found that when I guess when they have taken some of these sorts of half-hearted attempts at it, the results have not been good, and a lot of them come away with the feeling that, okay, this is data science and ML is more hype than reality, or something like that. Certainly high-paying data science roles, both on the sort of analysis side and on the machine learning side of things. But generally speaking, a person that is strong and highly skilled in both areas is definitely likely to do a lot better than a person that is strong in only one of them. So generally speaking, I would say there are a number of things on a checklist. The more items you can hit, the more valuable you'll be, and your likelihood of landing a higher paying job also increases. So certainly one thing I would put out there is ML fundamentals. Another thing I would, what I already mentioned, certainly I would put a very high degree of emphasis on, I guess, doing effective data exploratory data analysis, doing very effective sort of presentations of data, getting to the sort of gist of it easily, being able to communicate it easily. I would put a lot of emphasis on this as well. But I'm starting with these two just because I feel like these two end up getting overlooked a great deal. In addition to this, of course, definitely, I think strong programming skills, understanding something about backend and a bunch of other things again becomes helpful, because without those kinds of skills, you are not the person who will actually be taking various things into production. You're kind of relegated to building some toy prototypes and things like that. So this sort of thing, some knowledge and expertise with backend and systems as a software engineer, that is certainly helpful. It is also quite helpful to have some kind of, I would say, product management sense. And I'll tell you where this plays a role. Now, again, when you are when as a data scientist you want to go and unlock a lot of value, there are often it can be very, very tempting, to think of a job of a data scientist as not very different than say solving a Kaggle competition or something, but just doing it within the confines of a company. But that's not reality. The point is, companies ultimately interested a lot more in the question of what kind of value you can drive for them. They don't care how you drive that value. So now, often the more useful levers that you are capable of pulling towards driving that value, the more valuable you in turn will be to the company. So product becomes quite important because there might often be certain product features which have a certain interplay with machine learning. There's a certain kind of data one could collect from product, which in turn could maybe make your algorithms a lot better than banging your head against a brick wall with some very limited data, etc. That may be there in a certain iteration of a product. Like in the previous iterations of the product, things might have been built a certain way by people who are product managers and engineers without who do not have as much appreciation for the data as you do. So you may have useful things to say with regard to how such a thing itself should be built. And I do think an increasing number of products that we are talking about today are really data products whose job is to elicit the most useful data cheaply and efficiently, and be able to make smart decisions. So obviously, when you think in terms of how to build such a product, data science has to have a very firm seat at the table there as well. So yeah, I would say again, the more you as a data scientist are able to check off more of these boxes, the more incredibly valuable you become, the more you're likely to rise to leadership quickly, and so on. Since today, I think a tremendous amount of things get lost in the gap between, I would say, between data science and product and engineering. And if you're sufficiently strong enough to sort of straddle a bunch of these different areas, you could be tremendously valuable to the organization. I mean, I do expect this extent of whatever this kind of tension or a tug of war, if you will, to continue to play out for some more time. And this is, from what I can tell, happening everywhere. This is certainly happening in some companies in the US as well. Like some companies have embraced this a lot more wholeheartedly. In fact, some companies were on the remote work train even long before COVID, etc. And but yeah, I think in the long run, I mean, it is difficult to sort of fight against the tide of history. Like if you are the one company who insists everybody comes to office, you are and your competitors are not playing the same game you are playing, you're putting yourself at a tremendous disadvantage. And ultimately, I think these market pressures will more or less prevail. Like you put yourself at tremendous disadvantages by way of this one, by way of first of all, exposure to a much smaller talent pool. Now this may be okay if if you are something again, if you're a kind of service where talent is very plentiful, right? Like let us say again, you're some kind of a data labeling service. You probably are not going to run into that serious talent shortage problems, where for making each and every hire, you really have to think hard. Your recruiters have to work hard, etc. You're probably not that kind of a business. But if you're a business that wants fairly high skill talent of any kind, particularly tech talent, you're certainly putting yourself at a tremendous disadvantage, right? Like your competitors will be able to do speed, quality, cost, volume, everything a lot better than you, while you're still like scrambling to make your one hire. Maybe they have made 20 hires already. They have shipped various things in 6 months, etc. And yeah, I think this sort of thing is now some of the larger companies often end up being a bit more resistant to change. In fact, it's interesting that I would say it probably took a full year almost after the pandemic before a lot of large companies in the US even became as open to the idea. So I mean, I'm sure some of the same forces that make larger companies reasonably sluggish and uncompetitive and open up opportunities for startups. I'm sure the same thing even comes in terms of work models itself. For example, I'm sure the same thing, like we all wonder how is this startup able to ship this with just a team of 20 people while this large enterprise has been in this space for forever, etc. I think a lot of the same forces come up even when it comes to experimenting with a bunch of these new models. So I fully expect, yes, there will always be some degree of this shift. I cannot predict exactly what percent of people will want, companies will want people back in the office, what percent will not, etc. But ultimately, I think the companies that are attempting to grow fast, which are like tech first companies fundamentally, which rely on where tech is pretty much their bread and butter, they will pretty much have to be more and more open to this, and be open to a big chunk of their workforce being fully remote. So I think obviously these IT services companies do a mix of various things, right? There's a certain mix of there's a certain category of data labeling and such services they do, right. And they have large contracts around many of these, many things around BPO and all that. I don't think those are fundamentally going to get disrupted that much fundamentally by this wave. I think definitely when it comes to any kind of their high-tech offerings, when it comes to skilled software developers, from the standpoint of product development, not just maintenance, things like that. Yes, I do think it would be advantageous for them in turn to be open to fully this thing, fully remote talent. Not necessarily insist that people come in their office, etc. I think the exact same thing that will advantage every other company will probably start becoming table stakes even here. So for talented people who are at least strong with their various strong, let's say, technically in their various different areas relating to a job, etc., it does open up a tremendous amount of opportunities. Like in India, for example, definitely, I mean, if a person were to be, if a person wanted to live in a family in Assam or Patna or Shimla or some such place, their tech job opportunities might be relatively more limited today, and definitely I think this opens up a tremendous number of those sorts of opportunities. Like even today, for example, among the various talented people that work with us from India, both in our internal team and with our customers, they all come from a whole range of cities. A lot of them are home with families, and it's not they don't have this either or type of choice. Like, either I pick career or I pick being living at the place I want to live, and that I expect should overall be a large plus. In fact, I have heard that something like I'm a little bit of an economic history type of buff. So I've heard that, for example, 100 years back, people could only look for jobs maybe within like a 2 or 3 kilometer radius of where they could. And then their opportunities were even more limited. The probability that you're in a place where you can create maximum value is a lot more diminished compared to a situation where there even exists any form of a motorized commute, which increases that radius to some 15 kilometers or so. Now imagine that you can just be anywhere in the world. There needs to be no tech company within many hundreds of kilometers of where you live, but still there's you're exposed to the world's opportunities. Obviously, that has to be a very, very paradigm shifting outcome for you, regardless of the kind of skill you have. I mean, we at Turing, of course, focus primarily on software development, but when it comes to our customers, but we have found a lot of success when it comes to such hiring, even across various other functions for our own needs, to do with content writing, to do with various other sorts of roles and so on. And I do believe it will ultimately be win-win. Well, I mean, while in absolute terms we have done quite well at Turing, I think compared to the size of the opportunity itself, I think we are a very, very, very tiny drop in the bucket. I think the opportunity is so large that, while we talk about various various other companies, and sometimes it can be tempting to talk about them as competitors. In reality, everyone is competing against the status quo. I think we in terms of the size of the opportunity, maybe annual revenues of a few hundred billion and so on, all of us are like a tiny drop in the bucket. So I think a lot of companies have tremendous room to grow, and I think we'd like to keep growing as rapidly as possible in the coming few years. I mean, we'd like to ultimately be the primary place that companies, particularly, I would say, particularly in the US, possibly other parts of the world as well, to a smaller extent, like we see even today, come to Turing as the first choice for hiring, for doing speed, quality, cost, and volume at the same time when it comes to hiring. And likewise, we'd like to be the first choice for developers when it comes to again. This thing, access to a tremendously large pool of opportunities, being put in a position where in a job that is the right fit for them, which ultimately helps them produce maybe a lot more value than what they would have been doing otherwise. And if Turing is able to ultimately allow talented people to produce maybe 5x the value that they have been able to produce compared to in some alternative configuration where they might not have been as strong a fit for that particular company and role, of course, then there's a lot to go around. Turing has facilitated has helped this extra 4x happen. That in turn means we have created a very good outcome in terms of putting the developers in a position where they can get higher salaries, putting companies in a position where they get great value for money, and us to making a nice sort of recruiting commission from companies.